Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. We are on lesson 36 in your blue book, and we're learning how to add mixed numbers, and we're going to do a little bit also about rate in this lesson. So here we have 3 mixed numbers that we're going to add together, and we're going to do this in 2 different ways. Okay, we're going to add the numbers by first putting them in their improper form, and then we're going to add the numbers without putting them in their improper form. We're going to see that we get the same answer, and adding them without putting them in improper form is faster, so we're going to learn to do it that way. Okay, so the very first thing is we're going to change these all to an improper form just to remind ourselves how to do that. So 2 times 4 is 8, plus 1 is going to be 9/4, plus 3 times 8 is 24, plus 1 is 25/8, plus 7 times 2 is 14, plus 1 is 15/2. Now we know that we can't add those fractions together because they are not like denominators. So we're going to look and say, what is the smallest denominator of all? And we have an 8. I mean, the largest denominator that all of them go into. An 8 has a 4 in it, and 8 has a 2 in it. So we're going to multiply this one. 4 times 2 is 8. So we're going to multiply by 1 in the form of 2 over 2. There. And then over here on this side, we need 2 to go to 8. So we're going to multiply by 1 in the form of 4 over 4. So now when I simplify this, we're going to get 18 over 8 plus 25 over 8 plus 60 over 8. And now when I add up all the numerators, I'm going to get 103 divided by 8. So 103 divided by 8. Now I have to turn it back into a mixed number. Phew, this is a lot of work, isn't it? So 103 divided by 8. Let's pick a spot here. 103 divided by 8. 8 goes into 10 one time. 1 times 8 is 8. And we're going to get a 2. And we're going to bring down the 3. And we're going to get 8 into 23 is 2. And 2 times 8 is 16. And 23 minus 16 is 7. So we're going to get 12 and 7/8. So let's write our answer real big here. And we just did it the long way. Okay, so now we're going to get rid of all of this and all of this and all of this, and we're going to go back to the original problem. Now we're going to do it the easy way. Okay, so watch carefully. We're going to put the 3 and 1/8 underneath this one. We're going to put the 7 and 1/2 underneath that one. And so now we have a string here of 3 mixed numbers. And we're going to add the like parts together. So since I need this space, I'm going to take this away and this away because I've already written them again down here. Now when we're doing this method, which is much faster, we're going to leave the whole numbers alone. And we're only going to work with the fractions. So we're going to look at the 3 fractions, and we're going to say, what do I need to do to get them to where they have the same denominator? And don't I need to have a denominator of 8 on each one? Okay, now the very middle one there already has a denominator of 8, so that's not going to change. But 2 is going to multiply by 4 over 4 to get to be 8. So 2 times 4 is 8. 1 times 4 is 4. And up here on the top, we're going to multiply 4 times 2, but we're going to make that a 2 over 2 because we always multiply fractions by 1. Okay, so 2 over 2 is 1, isn't it? So we're going to get 2 eighths. So now we have 2 eighths plus 1 eighth plus 4 eighths. All of them have the same denominator. 2 plus 1 plus 4 is 7. And I get 7 eighths. Starting to look like that answer right there, isn't it? And then all I have to do is add my whole numbers up. 2 plus 3 is 5 plus 7 is 12. My answer is 12 and 7/8, which is what we got before. And I never had to turn a mixed number into an improper fraction, and I never had to turn an improper fraction back into a mixed number. I skipped all of that. I wrote the 3 mixed numbers in a column. I added the fractions together by getting a common denominator. I added the whole numbers together, and there's my answer. Now, occasionally when we do this, we will get a number that's bigger than 1 here, which means we're going to have to carry over here. But still, a lot less work than adding improper fractions. Okay, so we have another problem. Aren't we glad we have a new method? Because 528 times 3 is a big number, and 7,142 times 4 is a really big number. But we don't have to do that, do we? We're going to get an equivalent fraction and get an equivalent fraction for 3/4, and we need to go to the least common multiple. The least common multiple of 3 and 4 is 12. So we're trying to get to 12 on the denominator of both of those. Now, 3 times what is 12? Well, I need a 4 over a 4. And I wind up with 4/12, and 4/12 is the same thing as 1/3, isn't it? So then on the bottom, I'm going to multiply the 4 by a 3, but I'm going to make it 3 over 3, 9/12. Okay, so now we're going to add the fraction parts. 4/12 plus 9/12 is 13/12, which is an improper fraction. So we're going to have 1 carryover, aren't we? But we'll deal with that in a minute. So now we're going to add our whole numbers. 8 plus 2 is 10. 4 plus 2 plus 1 more is 7. 5 plus 1 is 6. And then a 7. Okay, so that is the right answer, but it's in the wrong form. We're going to change this improper fraction to a 1 and 1/12. Okay, so we're going to say that's equal to 1 and 1/12. So you can either write it or if you just change it. So the 1's going to come over here, and then this one's going to become a 1/12. So 1/12, and then add 1 more over here, which is going to make that 7, 6, 7, 1. There, you have it. So much faster. Let's try one more of those before we run into the rate problems here. Okay, so we have a whole number with a fraction as a mixed number, another mixed number, and now we have to just get those 2 denominators to be the same. But 5 goes evenly into 20, doesn't it? So I'm going to multiply the 5 by 4 over 4, which is 1. When I multiply something by 1, it doesn't change it, does it? So 3 times 4 is 12. 5 times 4 is 20. 12 over 20 plus 1 over 20 is 13. Well, that doesn't look like a very good 13. 13 over 20. Now that is a proper fraction. The denominator is bigger than the numerator. So I'm not going to have to carry anything over. 1 plus 4 is 5. 2 plus 7 is 9. 4 plus 2 is 6. And we have our answer. Okay, so now we're talking about rates. And a rate is a ratio. And a ratio is a comparison of two numbers. And an example would be 2 apples for 16 cents or 16 cents for 2 apples. They both mean the same. You're going to purchase 2 apples for 16 cents. Okay, or maybe sell 2 apples for 16 cents. Okay, so when we're looking at these, we can simplify these ratios. And if I were going to simplify this one, I could take the 2 and the 16, and I could say, oh, I can divide the top and the bottom by 2, and then I would get 1 apple for 8 cents, okay? Or 1/8 of an apple per cent. Okay, now you wouldn't go around buying 1/8 of an apple, would you? That's kind of funny. But that's the way we could simplify it. We could say 1 apple for 8 cents, which makes more sense, or 1/8 of an apple per cent. Okay, so over here, it's the same thing, but it's written upside down. We could simplify the 16 and the 2. 16 divided by 2 is 8. So we could say 8 cents per apple, which makes sense. Okay, so a lot of times we will use the word per to express the rate. Instead of putting it in a fraction, we might say here 8 cents per apple. So whenever you see a per like that, per, not like a kitty cat purrs, but a per, P-E-R, then that means for each. So 8 cents for each apple is the same thing as 8 cents per apple. And we can write it out in words instead of write it as a ratio like this, which you will often see. This next example, it says that Waldo bought 5 toys for $40. Now, when we have 5 toys for $40, we could write that in 2 different ways. And the first A part, they said, what was the rate or ratio in dollars per toy? So dollars per toy means that dollars is going to go on top and toys is going to go on the bottom. So instead of 5 toys for $40, we're going to do $40 for 5 toys. We just flip it over. So now 40 divided by 5 is 8. So $8 over 1 toy, or $8 per toy. So that was the answer to part A, and that was dollars per toy, and they're $8 per toy. And then the B says, what was the rate in toys per dollar? So go back to this board here, and toys per dollar would be the way it was written the first way, 5 toys per $40, which when I divide by 5 on the top and the bottom, I get 1 toy for $8. And then I can put these together and I get 1/8 toy per dollar. Now, nobody's going to buy 1/8 of the toy. So this one might be a little bit more easier to look at, 1 toy for $8, but they wanted to know how much for $1. So this is the correct answer, 1/8 of a toy for $1. All right, here is our A practice problem. So copy it down on your paper and pause your video. Okay, so this is one of the easy ones, and we're going to do it the easy way. We're just going to bring the 3 1/10 down below. Now you can do it out horizontally, but I like to do them this way. And we're going to go ahead out here and write down our new denominator that we want, 10 and 10, because the 5 will go into the 10. So this one we're going to have to multiply by 1 in the form of 2 over 2, and we end up with 2/10, which is the same as 1/5, and 2/10 in here, this was already 1/10. We're adding, so 2 plus 1 is 3/10, which is a proper fraction, and 2 plus 3 is 5. And so we are done with that practice. Okay, so here we are adding, and I don't want to have to turn those into improper fractions. That would be a lot of work, and it's good. I don't have to do that. So we're just going to get a common denominator of 20. So if I'm trying to get to a 20, don't I want to multiply by a 4 over 4? So 2 times 4 is 8, 5 times 4 is 20, and my new fraction is 8 over 20. Then 3/4, I'm trying to get to 20 at the bottom. So 4 times 5 is 20, so we're going to multiply by 1 in the form of 5 over 5. 3 times 5 is 15, 15 over 20. So now we're adding them together. 8 plus 15 is 23 over 20. Uh-oh, we have an improper fraction, but that's not going to be a big deal. We can just take care of that the next step around. So let's do this. 2 plus 2 is 4. 7 plus 1 is 8. 4 plus 3 is 7. And now we're going to take 1 away, which means we can take away 20 over 20 because 20 over 20 is 1. And we're left with 3 over 20. And we add the extra 1 over here, and we get 785. Done deal. And very, very fast. Okay, the next problem says Roger could travel 48 yards in 6 seconds. 48, not 46. I miscopied it. There, we've got it right. 48 yards in 6 seconds, okay? And what was his rate in yards per second? So first of all, let me get this one right over here. 48 yards, 6 seconds. 6 seconds, 48 yards. So it says first, what was his rate in yards per second? Well, this one already has yards on the top and seconds on the bottom. So all I need to do is simplify that as much as I can. 48 divided by 6 is 8. 8 yards per second. If we use the per, we can do without the fraction, okay? And then this one, it says in the second part, what was his rate in seconds per yard? So now 6 over 42 is what I'm going to simplify, and that is 1/8. So we're going to have 1/8 second per yard. All right, here's our last practice. It says 8 apples can be purchased for $2. 8 apples per $2. What is the rate in apples per dollar? And what is the rate in dollars per apple? Apples per dollar would be that direction. Dollars per apple would be the one on the bottom. Okay, so they're both rates, but we're going to have to give the rate that they want us to give. So we're going to simplify this rate and make it in apples per dollar. Okay, so 8 over 2 is 4. 4 apples per dollar. So now we have to do it the other way. So we have $2 per 8 apples, and when we simplify this, it becomes the fraction 1/4. 1/4 dollar per apple. And there you have it. That is the end of lesson 36. And this is Mrs. A, and may God bless your day.